Hello students, in this lecture we see the examples of the chapter Determinant and Matrices in the exercise 4.2. Okay, here examples depend on the properties of the determinant. Okay, here the question is, without expanding evaluate the following determinant. Here without expanding, we know how to expand the determinant and how to find the value of this determinant by taking the expansion of this determinant here by along the first row, second row, or third row. We can take along first row. Okay, see carefully. Here we can write the answer of the first. Here, let it is a D determinant. See carefully. It is a 1 A and it is B plus C. Then 1 B and it is C plus A. Then 1 C and it is A plus B. Here, evaluate this determinant. Okay. Evaluate this determinant without expanding. Okay. Without expanding. That means we use the properties of determinant. Okay. We have already seen the properties of determinant. There are 8 properties. Okay. Here, if the row and columns are the interchange, then the value of determinant does not change. Okay. If any 2 rows or any 2 columns are interchanged, then the value of determinant changes only in its sign. Okay. And third property, if any 2 rows or any 2 columns are equal, then the value of determinant is 0. It is the third property. Then after that, if we multiply all elements in a row or a column by a number k, then the obtained determinant, the value of the obtained determinant is k times the original. Okay, that means we multiply all elements in any row by a number k, or we take a common of all elements. Okay, we take a number in all elements in a row or column. Okay, here, or when we perform the transformation, that is the row transformation or column transformation, then the value of determinant does not change. Transformation means the calculation between any 2 rows or any 2 columns. Okay, here that means addition between rows, subtraction between rows. Okay, in general we can write the row I. Okay, in general the transformation can be written, it is Ri plus k into it is R. That means we multiply any one row by element by a number k and adding the another row. Okay, here it is a transformation. Okay, or column transformation. Okay, here these properties. Okay, using these properties we can find the value of this determinant. That means without expanding. Okay, without expanding means by using the properties. And here we know the property. Here it is a 1 1 1. If any 2 rows or any 2 columns are the same, then the value of determinant is 0. Or we can take a common. We can take a common element. Okay, any element here. Here 1 1 1. We can take common. It is one common, or not taking a common. There is no. Here. Now here it is A B C. All are the different numbers. So cannot be common. Okay. Here in the third row, second row, first row, there is no common element. Okay. Here, see carefully in this example. Okay. There is 6, 9 and 12. X, X, X. In the third row, we can take a common X, or it is a 3X. We can take a common 3X. Then here remaining 2, 3 and it is a 4. Okay. In the second example, in the third row, we can take a common 3X. But in this determinant, okay, there is no common value of all elements in the row or column. Okay. So here we use the transformation. Okay. Transformation, that means addition or subtraction of any 2 rows or any 2 columns. Okay. Here 1 1 1 are the same, but here B plus C, here C plus A and it is A plus B. When we added the column 2 and column 3, then it is A plus B plus C. Again it is A plus B plus C because it is C and A plus B. AB and it is C. Here we perform the transformation on the C. Here it is a C3, that is a column 3. Okay. Column 3 can be written as C3 plus C2. Okay. Here see carefully, therefore our determinant is equal to first column as it is, 1, 1, 1. Second column as it is A, B and C. And now third column replaced by C3 plus C2. C3 it is C3. B plus C and plus A. It is A plus B and plus C. C3 plus C2. C3 plus C2. It is a C3 and it is C2. C plus A plus B. That means again A plus B plus C. And it is third. It is A plus B plus C. Now this number A plus B plus C, A plus B plus C, A plus B plus C, all are the same. So in column 3, okay, in column 3 we can take the common number A plus B plus C. Okay, here taking A plus B plus C common from C3. Okay. Then we get here, we can write here, see here. Therefore, the determinant is 1, 1, 1. Sorry. We can take a common A plus B plus C from the column 3. Then determinant is, we can take a common A plus B plus C. And into determinant of 1, 1, 1. First column as it is. Second column as it is. And in the third column, we can take the common A plus B plus C. A plus B plus C. Then here remaining 1, 1 and 1. 1, 1 and 1. And now, here C1 is equal to C2. Sorry, C1 is equal to C2. And therefore, the value of determinant is equal to 0. Without expanding the determinant, we can find the value of this determinant. Here, we perform the two transformations, C3 plus C2, and here, taking common from column 3, it is A plus B plus C. When we take a common, okay, here, this determinant is 0, and it is A plus B plus C, it is a value, okay, we can take one more step, it is A plus B plus C, it is a common element, and into 0, and then it is a 0. Okay. That is, it is the value of this determinant without expanding. Okay. Now we see the second example. Here, the second let it is a determinant. 2, 3, 4, 5, 6 and 8. 6x, 9x and 12x. See carefully. From row 3, take a common 3x here, 3 and it is x. Okay. Then we get it is a 3x into first row as it is 2, 3 and it is a 4, 5, 6 and 8. When we take from row 3 common 3x, here we get 2, 3 and 4. See carefully. We can common from row 3, it is a 3x. Then we get 2, 3 and 4. And here we observe that row 1 and row 2 are the same. Therefore, the value of determinant is again 0. And value of determinant 0, that means 0 into 3x, again it is 0. Now here R1 is equal to R3. Row 1 and row 3 are the same. Therefore, determinant is equal to 3x into 0. It is a 3x and the value of determinant is 0. And then last answer is 0. That means again the value of this determinant is also 0. Now we see the third example. here in the third example, let b is equal to, it is a 2, 7 and it is a 65, 3, 8 and it is 75, 5, 9 and 86. Here, we want to find the determinant, the value of determinant without expanding. Just see carefully, without expanding. So here we use the property, and properties are when two rows or two columns are the same, then the value of determinant is 0, or we perform the transformation, row transformation or column transformation, then the value of determinant does not change. Okay. Here any two rows or any two columns does not like this, it is a look like the same. It is a 2, 3, 5, 7, 8, 9 and it is 65, 75 and it is 86. So first we perform a transformation. Okay. Here it is R1, R2 and R3. Take the relation between these two numbers. When R2 minus R1, see carefully, R2 minus R1, it is a 3 minus 2, here 1. 8 minus 7, again it is 1. And 75 minus 65, here it is a 10. Okay. When we perform, see carefully, when we perform R2 minus R1, we get it is a 2, 7 and 65 as it is. When we perform R2 minus R1, we get here 1, 1 and 10. Okay. And again perform R3 minus R1, R3 minus R1, here 2, 2 and but here it is a 21. Okay. Here, if okay, here it is 85, then we get here 20 and take a common 2 from the third column, then 1, 1 and again 10 and the value of determinant is 0. But here not a given, it is not a 85, okay, it is 86, so it is 1. So we cannot perform this transformation because after using this transformation the value of determinant cannot be saved. Okay. Here after expanding you can say the find the value of this determinant, but question is without expanding. So the row transformation we cannot be performed, we perform the column transformation. Okay. Now in the two columns, any transformation between any two columns, see carefully. Okay. Transformation between any two columns. Okay. See check the relation between numbers. Here it is a 65 and it is a 7. Okay. 65 and 7. When we take a subtraction, there is a difference between 65 and 7 is long difference. Okay. It is 7 and 65. But when we multiply 7 by 9, it is a 63. See carefully. When we multiply by 9 by 7, it is a 63. And then 65 minus 63, here it is a 2. Okay. Here we multiply by 7 by 9, but it is a 7 in the column 2. We multiply only, we cannot be multiply only one number. We can multiply all elements in the row or all elements in the column. When we multiply this number by 9, we multiply by this number by 9. When we multiply this number by 9, then it is a 72. And again, it is a 55 minus 72. It is a 3. Okay. Here it is a 2. Here it is a 3. And here, again multiply here by 9. It is 81. It is a 86 minus 81. It is a 5. That is 2, 3 and 5. Here it is a 2, 3 and 5. Then column 1 and column 3 are the same. Then the value of determinant is 0. But here transformation is C3 minus 9 C2. Okay, transformation is C3 minus, see carefully. Transformation is C3. We can change the value of C3. It is C3 minus 9 C2. Then determinant it is column 1 as it is, column 2 as it is. But in the column 3, we can write this value C3 minus 9 C2. Okay. We multiply all elements in the column 2 by 9 and then C3 minus 9 C2. We multiply all elements which is a 9, then it is 63, 72 and it is 81. Okay. Here it is a 63, 9 into 7, 63, 65 minus 63, we get 2, 75 minus 72, we get 3. 86 minus 81, we get 5. And here, the value of determinant it is a 0. Okay, because C1 is equal to C. C1, column 1 and column 2 are the same, then the value of determinant is 0. Okay, we can solve all three examples without expanding. Okay, that means by using the properties of determinant. Now we see the next. Now the next example. Question number 2. Prove that determinant of x plus y, y plus z, z plus x, z plus x, x plus y, and y plus z. Then y plus z, z plus x, and x plus y is equal to 2 into determinant of x, y, z, z, x, y. And y, z, x. Now, so given determinant it is this, and then we have to prove the value of this determinant is equal to this. Okay, here x plus y, y plus z, z plus x, but we want to 2 into determinant. That means we can take a common from any one row or any one column by 2. Then we can write this 2 outside the determinant. Okay, here. But there is no number 2 in any rows or any 2 columns, or it cannot be common 2. Okay. So first we perform the transformation, row transformation or column transformation. Okay. And then reduce this determinant in the form of this determinant. Okay. Here, see carefully. Here it is a LHS is equal to x plus y, y plus z, that is z plus x, z plus x, x plus y, and y plus z, y plus z, z plus x, and it is x plus y. Okay. Now it is given. First we perform. Here we can find the 2 common in any row or any 2 columns. Okay. Here, therefore, we adding the first row and second row. Then we get it is a 2x. Okay. Here. Now there is no number 2 in any column, or we cannot be common in any row or any column by number 2. So first we add the row 1 and row 2. Here, first transformation. See carefully. It is R1 plus R2, R1 plus R2. Then we get the determinant. See carefully. R1 plus R2. Okay. The element in the R1 it is x plus y, y plus z, and it is a z plus x. And elements in the R2 it is a z plus x plus y, and it is y plus z. We can add in the R1 and R2, and this R1 plus R2 we can replace to the row 1. Okay. Therefore, row 1 च्या जागेवर काय लिहायचे? It is R1 plus R2. R1 plus R2, x plus y and z plus x. That means 2x plus y plus z. Here, yeah, addition. Okay. Then adding these two corresponding elements. X plus 2y plus z. X plus 2y plus z. And third number it is x plus y plus 2z, and remaining 2 rows as it is, z plus x, x plus y, and is y plus z. Third row as it is, y plus z, z plus x, it is x plus y. Here. Now, again see carefully, here it is a 2x, it is y plus z. Okay, it is y single and it is z. Here y plus z, see carefully, it is y plus z. We are adding again here row 1 and row 2. Sorry, it is row 3. Now, we are adding in this determinant row 1 and it is row 3. Okay. Now, R1 replaced by R1 plus R3. Okay, see carefully. R1 replaced by R1 plus R3. Then, here, R1 2x plus y plus z, and it is y plus z. Therefore, it is 2x plus 2y plus 2z. 2x plus 2y, it is y plus y, and it is z plus z. Then, x plus x, 2x, 2y, and it is z plus z, 2z. Again, it is 2x plus 2y plus 2z. Again here 2x plus 2y plus 2z. Okay. And row 2 and row 3 as it is. Z plus x, x plus y, and it is y plus z. Y plus z, z plus x, and it is x plus y. And now in the R1, we observe that here 2, 2, 2. Okay, there 2 get common. And in R1, all elements in the R1 here 2, 2, 2, 2, and here 2. We can take common 2 in R1. Okay, here take common 2 from R1. Okay. Then we get the determinant. Here we can write here. It is a 2 in determinant of x plus y plus z. X plus y plus z. It is x plus y plus z. And row 2 and row 3 as it is. Z plus x, x plus y, and y plus z. Y plus z, z plus x, and x plus y. Here, we have to prove this 2 into x, y, z, z, x, y, and y, z, x. Here, 2, the first term for our RHS, it will become here, we get 2. Now, we get here x, y, and z. See carefully, we get in the row 1 only x, y, and z. Here it is, we have x, so y and z will be cancelled. Okay, y and z will be cancelled. So we minus R3. Here it is y z. R1 minus R3. R1 minus R3. R1 minus R3. We get x, y, and z. Here R1 minus R3, y and z get cancelled. We get x. R1 minus R3. Here x and z get cancelled. We get y. And R1 minus R3. X and y get cancelled, we get z. Okay, see carefully. We transform R1 minus R3. Then we get it is a 2 into determinant of. See carefully the calculation. We can change only R1, R2 and R3 as it is. We can write first R2 and R3. See carefully. Here it is a z plus x, x plus y, and y plus z. It is R2. Y plus z, z plus x, and x plus y. It is R2. See carefully. We can write R1. And here R1. It is R1 replaced by R1 minus R3. It is R1 x plus y plus z minus R3. That is y plus z. Here we get x. R1 minus R3. We get y. R1 minus R3. We get z. Now, for our answer here 2 and first row we get x, y, z. Now we have to find the second row z, x, y, and in the third row y, z, and x. Again see carefully. There is second row Z, X and Y. We get Z, that means X will be cancelled. So we subtract R1, sorry, it is R2 minus R1. R2 minus R1. R2 minus R1. And here we get Y, Z and X. R3 minus R1. We will perform two transformations in one step, or we will perform step by step. Okay. Here R2 minus R1. Then it is 2 into X, Y and Z as it is. See carefully, X, Y, Z as it is. R2 replace, it is R3 again as it is. Y plus Z, Z plus X, and it is X plus Y. R3 again as it is. We can change R. Okay. And here R2 minus R1, R2 minus R1. Here we get Z. Z plus X minus X. X plus Y minus Y. It is X. Y plus Z minus Z. We get Y. Okay. Here we get the second row. And now last. R3. R3 minus R1. Okay. Then it is a 2 into R1 as it is, R2 as it is, and R3. It is R3 minus R1. R3 minus R1. No, sorry. Here R3 minus R. R3 minus R. We are to Y. Therefore Z will be cancelled. Y plus Z minus Z. We get Y. Z plus X minus X. We get Z. And if X plus Y minus Y. We get X. And then it is RHS. Let's see here. We perform the transformation here. First R1 plus R2. R1 plus R3. Then R1 minus R3. Then R2 minus R1. And it is R3 minus R2. R3 minus R2. We get this determinant. Okay? Check all the transformations carefully.